Sometimes you are asked a question like this one. You are told that there is a circuit whereby we have a resistor and we have another type of resistor, and if you are asked which type of resistor is this, you will tell the examiner that this is called a variable resistor. And a variable resistor is a type of resistor whose resistance can be varied, can be changed, can be adjusted. Now we have a 5 ohm resistor, we have a 3 ohm resistor, which is a variable resistor, and all these are supplied by the EMF voltage of 10 volts, and a current I is running through the circuit. So you are supposed to find the current I. What are you supposed to do? So in that case, for you to work out this question, the first thing that you need to realize, we are going to find the total resistance in the circuit. The first thing you need to know the total resistance. So we are going to say R total. Because these two resistors are connected in series, it means we are going to add the resistance R1 plus R2. And in this case, our R1 is 5 ohms and our R2 is 3 ohms, which translate to 8 ohms. So this is the total resistance in this particular circuit. Then we're going to apply Ohm's law, and Ohm's law, we know that from Ohm's law, V equals to IR, whereby V is the voltage, I is the current, R is the resistance, and in this case we're going to use the total resistance which we have gotten here. So meaning that our current, if we make it subject, it would be V over R, which is going to be 10 divided by 8. Working it out here, we're going to get the value of the current is going to be what? We are going to divide 10 divided by 8, 10 divided by 8. We are going to get our answer as 1.25. So our final answer is 1.25. So the current that is running around the circuit is 1.25 amperes. So something that you need to remember, current at this point is 1.25 amps. Current at this point is 1.25 amperes. Current in a series circuit is the same throughout. The current that is passing through this component is the same current. So for us to state the reading of the voltmeter here, we are going to consider that the current that is going to pass through here is also 1.25. Then how will we work out the voltage across this 3 ohm resistor? Because the current that is passing here is 1.25 and the resistance is 3 ohms, then the voltage is going to be current times the resistance of the 3 ohm resistor. Are we together up to that point? All right, so this is going to be 1.25 times 3, and if you multiply that by 3, you are going to get 3.75 volts. This is the voltage drop that will be recorded by this voltmeter. Now, always, sometimes you'll be told to add a voltmeter to measure a given voltage. It should be connected parallel. Always a voltmeter is connected parallel. So if maybe you are asked to connect a voltmeter to measure the voltage for the 5 ohm, you are going to do what? You can add it somewhere here, and that is our voltmeter to measure the voltage drop across this. Something that I need to mention also is that the voltage drop here plus the voltage drop here should add up to 10 volts. So in the event if they asked you to work out also the voltage drop 5 ohm resistor, you are going to take 10 minus the answer you got here. But at the same time, you can work it direct by saying the current times 5. You will get the same thing. If you got value from this particular video, consider subscribing so that anytime I upload a tutorial, you'll be notified. I've realized most of my viewers, you have not subscribed. Support the channel by subscribing. Also share this video to any of your friends. See you in the next video.